All right, everybody, I want to run through this problem here. So we have the lawnmower problem. And I worked it out before, but the video didn't upload as well as I wanted. So I'm going to walk you through what I did. So first of all, what I'm doing here is I'm drawing a free body diagram where I have a normal force, gravity, friction, and a pushing force. And I've resolved the pushing force into two components, which is the x and the y component. Next, to get the normal force, I am basically taking the vertical components of the normal force, Fg and Fy, Fpy. So the up component is the normal force, and the down is gravity, and the y component. And when I combine those, I'm going to get a total normal force of 900 newtons. Now, to get the maximum possible static friction force, that's going to be mu times the normal force, which is 270 newtons. And to determine whether it moves, we're going to calculate the x component of motion right here as 173 newtons. So 173 is less than 270, so the answer is no, it does not move. Now, in the next section, it turns out that we do need to kind of work the problem over from scratch. So just to be clear on all these problems. First, free body diagram. Next, x and y components of the applied force. So that ends up being 236 and 42. Next, after that, normal force. So Fn minus Fpy minus Fg equals 0. That's how we're getting 842 newtons. From there, we calculate the maximum possible static friction as 0.15 because we have a new coefficient, times the normal force, which gives us 84.2 newtons. Comparing, the horizontal component of force is 236 versus a static friction of only 126. So yes, we do move. But now that we know we're moving, we're going to switch over to kinetic friction. So we're going to have 236 minus 84.2 is going to be 80 times a. And when we simplify, we're going to get an acceleration of 1.9 meters per second squared. For the last part, when you let go of the lawnmower, you now switch to a situation where there's no pushing force. You've got to recalculate the normal force, which we get here. From there, we recalculate the normal force as 800. Then we recalculate the friction. And we're going to use the fact that the friction always slows you down. So it's negative friction equals the mass times acceleration. So we get an acceleration of 1. Lastly, we're going to plug that into Suvat and get a time of 2 seconds.